and composite. I can identify prime and composite numbers. So I want you to take out your notebook and draw that line down. You do not have to write any of this, but in your notebook, you'll notice I skipped the number 1, but I want you to write 2, 3, 4, 5, and 6, and then start a new line, 7, 8, 9, 10, all the way to 60. So stop the video now so you can number your notebook. All right, welcome back. What you've just created is the sieve of Theseus. He was a Greek mathematician who figured out a pattern in numbers. So he started by circling the 2. So we circle the 2. We're going to cross out all the multiples mean they get bigger. 2, 4, 6, 8. So let's cross out all of its multiples and continue on. What you should start to notice is what you are crossing off 2 can go into, or 2 is divisible, or I'm sorry, these numbers are divisible by 2. So 2 can go into 36 evenly. 2 can go into 42. You should also start to notice they create a pattern going down. They create a column. Each of those columns can be then crossed off. What you're left with are all odd numbers. So let's do the next direction. Cross out 3 and circle 3 and start crossing out all of the multiples of 3. So that's 3. 6 is already crossed off, so let's do 9. 12 is crossed off, so we're up to 3, 6, 9, 12. Yep, you're right. 15, 18, 21, 24, 27. You'll start to see a pattern. 30, 33, and down this column. So again, 3 can go into each one of those. 4 is already crossed off because it was a multiple of 2, so let's do 5. So let's do multiples of 5. 5, 10, 15, 20, 25. You'll see a pattern going diagonal. 30, we have to cross off 35, 40, 45, 50, and 55. 6 is crossed off, so let's circle 7. The multiples of 7 are 7, 14, 21, 28, 35, 42. And then 7 times 9 is 49 and 56. We could continue this pattern. 8 is crossed off, multiple of 2. 9 was a multiple of 3. 10, a multiple of 5. So we can go to 11. It hasn't been crossed off yet. When we start crossing off all of its multiples, well, you'll notice they're already crossed out. 11, 22, 33, 44, 55. I want you right now to go circle everything else. And what you should notice is what I have written over here. All the numbers that we have circled are called prime numbers. So all the circled numbers are prime. So let's get what a prime number is. A prime number is a number that can only be divided by 1 and itself. Here's just a list of prime numbers. You don't have to write them because you already have them on your chart. So the only thing that can go into them is 1 and then the number. So 5 can only be broken down into 5 and 1. That's factors. The factors of 11 are just 1 and 11. Composite then has 2 or more than 2 factors. So if you take a number such as, let's do 12. 12 is composite. It's not prime because yes, you have 1 and 12, but you also have 2 and 6 and 3 and 4. So it has more than just the 1 and the 12. These are all factors of 12, so that makes it composite. Welcome back. We're going to take some numbers and just see if we can come up if they're prime or composite. So for instance, 24. Let's use a T-chart. What can go? Let's start with 1. 1 and 24. Can 2 go into 24? Yes, because it's even. So 2 and 12. Can 3 go into 24? Well, remember from divisibility rules, if you add them together, you get 6. So 3 does go in there. 3 goes in there 8 times. 4 go in there. 4 goes in there 6 times. Can 5 go in there? The answer is no. Can 6 go in there? The answer is yes, so you've come back around. You have found all of its factors. Since there's more than 1 in itself, this number is composite. All right, let's look at 13. Let's create a T-chart. Start with 1. Can 1 go into 13? Yep, 13 times. Can 2 go into 13? Nope, because it's not even. Can 3 go into 13? Well, 1 plus 3 is 4. 3 can't go into 4. Can 4 go in there? The answer is no. Can 5? No. 6? No. What you're starting to find, if we wrap back around, there's no numbers that go into 13 but 1 in 13, so that is prime. All right, you can get on.